There's a number of robots that have contributed to the success of the industry field. They carry out operations by moving items from one place to another and assembling all sorts of goods. These robots vary in their jobs as well as their motion enablement, but they all have the common goal of improving efficiency. This efficiency shows in how our products are made and how long it takes to make them. These robots were created for the purpose of helping humans throughout the years, and that's exactly what they have done.
There are many different types of robots in the industry field, including the Cartesian robot. It was created in 1969 by Victor Scheinman at Stanford University and is one of the most common types of industrial robots. The Cartesian robot has 3 arms that each function along linear axes of control, and they correspond to moving the wrist up and down, in and out, and back and forth. It is a computer numerical controlled machine that simplifies the robot's control arm solution. They can perform complicated movements and easily carry heavy loads and move it quickly to where it needs to be. Manufacturers are increasing the use of both Cartesian Type 6 axes. This type of robot usually can offer high levels of precision and repeatability. It is also easier to program and one of the simplest of all stationary robots. If you compare the Cartesian to other types of robots that can do the similar tasks, Cartesian robots are cheaper than their counterparts. It costs around $500 to $20,000. The Cartesian is often compared to SCARA, which both provides excellent solutions for assembly and packaging applications. But each robot has their own unique features and advantages. It can vary to sizes to 600 to 300 millimeters or even up to 1,000 and 1,000 millimeters. The Cartesian robot is capable of X, Y, and Z directional movements. Its application require movements such as straight lines and intersections. The Cartesian is a strong, dependable mover, but also requires special covering when it's working in hazardous environments. For example, they are not able to work underwater. They are mechatronic that use motors and linear actuators to position a tool. They also automate tasks to isolate cycle times and eliminate bottlenecks that are slowing down your production lines. The Cartesian robot is used a lot in the industry field. It's used for assembly operations, eliminates bottlenecks and other tasks. They can reduce the complicated movements and enhance usability. It also saves the decision maker in cost, training, and maintenance. The cylindrical is also somewhat similar to the Cartesian robot since it moves objects to place.
Before robots, humans in the manufacturing business would work day and night working all by hand. Humans require more to be satisfied, while robots do their job without any complaints. One of the robots that work in the industry is a cylindrical robot. It makes life in the manufacturing business easier. The first model was made in 1985. It is based off a human arm and operates like one too. In the manufacturing field, robots conduct tasks such as handling or moving heavy objects, gripping, welding, and many more. The cylindrical robot is versatile to the manufacturer. It could do many assignments that would take 2 to 3 robots to do. The cylindrical robot is old but can still be very useful to the manufacturer. The cylindrical robot isn't as spectacular as the other robots in industry, but it can still be useful for simple tasks. Since it was made in the 1980s, others had time to develop and innovate to make the robots better. The cylindrical robot is unique and is useful because of its cylinder-shaped movement. It has a huge impact and helped the industry business advance tremendously. But I feel that the cylindrical robot is too old. It can still come back into business if manufacturers choose to develop the machine even more.
Robots in the industry. The Unimate is a spherical robot, which is another name for polar robot. A polar robot is a robot arm first made in 1961. It is used in the industry for the purpose of manufacturing. However, the first polar robot, the Unimate, didn't turn out too well. It would sometimes drop boxes containing valuable materials. This robot head began its work at General Motors. It was said at the beginning of time it was used for a die casting spot. Eventually, they have found out that it had the ability to be something more useful. The manufacturer had created this robot Unimate. The robot's speciality is to manufacture. These spherical robots are needed mostly since we are becoming a bit lazy. The Unimate weighs 78 pounds, the width is 12 inches when the height is 37 inches. The Unimate was tall but an arm now. It can be like a mini construction crane. As the Unimate released, a man decided to create an actual robot arm made completely just for manufacturing. The Stanford arm was made by Victor Steinman during 1969, who was just a student working at a Stanford lab. The arm is made of electric and is also a main reason why we know how to form these arms today. This technology will change us mostly with the fact that it will take the jobs of many workers. In my conclusions, I've talked about the Unimate robot. It is a very important robot after all. It was the reason why there was the Stanford arm and why the Stanford arm is used for manufacturing today.
Robots have influenced the progression of the industry field for the past 100 years. It started with first programming robots, then moved to assembling and spot wheeling. The SCAR robot is perfect for the field of industry. It's chosen because of its precision and high-speed assembling. It is used to accomplish many operations like moving items, mass-producing objects, or accessing locations humans cannot. Due to the parts such as the joints and the wrists, the range of motion is less limited than other robots in this field. SCARs have small frames yet deliver the speed and precision needed to assemble products in an organized manner. SCARA robots were first created in the year of 1978 by Professor Hiroshi Makino at the Yamanashi University in Japan. But it wasn't until 1981 that SCARA robots were being used for commercial assembly lines. SCAR is an acronym for Selective Compliant Articulated Robot Arm and moves exactly like what it's trying to mimic. The joints of these robots are able to be waterproof in order to function underwater. The wrist cannot tilt but has the potential to rotate. It may have limited movement, but the wrist has an advantage in the assembling process. It helps assemble products with excellent precision at high speeds. It's perfect for the mass production of small electronic products, considering it cannot handle a large amount of weight. SCAR robots do not just excel while assembling products. They are also outstanding at a task called pick and place, which is when the robot moves an item from one location to another. These robots cost very little to manufacture and perform at great rates. SCAR robots are known to have the best price-to-performance ratio compared to other robots that do similar tasks. SCAR robots were created with the ability to execute various jobs and are one of the most popular robots in the field of industry. They complete tasks in shorter amount of time and do things humans cannot do themselves. Peter Cavallo, robotics section manager at Denso Robotics, states, because of their speed, ruggedness, and durability, SCARs generally are the first choice of manufacturers. Like the SCAR robot, Delta robots have multiple joints, making it more flexible than the typical robot.
For many years, robots have been created to facilitate work in the industry. Many of them were used to make picking and packing easier in factories so that workers don't have a lot of work to do. One specific robot that helps do this is the Delta robot. The Delta robot was designed by Professor Raymond Clavel in 1985. His idea was to use parallelograms to build this robot. The robot has 3 transitional and 1 rotational degree of freedom. This robot is basically used upside down because the base is on top with the motors attached to it. With the motors on top, the arms stay light, meaning that there is low friction, low inertia, low power motors, precision, speed, and fast acceleration and deceleration. These things make the Delta robot very useful in factories that need fast pick and place. An example would be the IRB 340 flex picker, which is used in the food, pharmaceutical, and electronics industries. It had an integrated vacuum system capable of rapid pick and release of objects. It was capable of 150 picks per minute. Not long after Professor Clavel designed this robot, the robot established itself as one of the most successful parallel robot designs, with several hundred active robots worldwide. In conclusion, the Delta robot is very useful in helping workers pick and place objects. This robot is very useful like many others. It helps with big tasks because not everybody is able to do the work that this robot can. Without this robot, many things would be left to be done, even with other robots that do similar work. Overall, these robots are very helpful, useful, and needed in the industry. These robots help complete tasks that are complex and would otherwise require a large amount of people in order for the task to be done. They help give us a lot of the packaged things that we need, like food and medicine. Without these robots, we would have much less of the packaged things that we all want or need.